So today I want to talk about something that everybody should do once in their lives. So we have all seen laws of reflection and refraction. Anyone remember what is the law of reflection of light? Yes?
This is also doing the incident angle and the
Yes.
Okay, they're always the same.
So we all know that the law of reflection of light says that if the light is incident on a surface, the angle of reflection and the incident angle will be equal. But we don't necessarily know where it came from. So that's what we're going to try to prove today. And number two, what do we know about the law of refraction? Yeah? What do we remember about Snell's law? Sine of theta 2, where N1 and N2 are the refractive indices of the respective mediums. We have all learned this since we were very, very young, right? But we don't necessarily know where it came from. So from people from math physics, do you remember where Dr. Faust started? And he called something the variational principle. We are not going to do calculus, but I'm going to show you how those things developed into those complicated variational principle problems. And it's actually quite interesting if you look at the history of how these things developed. Today, we're going to talk about the two different ways that the laws of reflection and refraction developed. What did we talk about last time?
We talked about a lot of things. We're going to have a few more.
We talked about optics, the two different kinds of optics. What were they? Geometrical, very good, and physical. Good. So wavelength cannot be ignored in physical optics. So in the limit, when delta is very small, physical optics becomes geometrical optics. So we are going to approach this problem from technically both sides of the spectrum. One, we are going to consider rays, and the other ones we're going to consider the wave fronts moving forward. So law of reflection says when a ray of light is reflected at an interface dividing two optical mediums, the reflected ray remains within the plane of incidence and the angle of reflection equals the angle of incidence. What does that mean? If I draw it, so imagine that this is my plane. This is the normal to the plane. And if I have an incident ray coming in, I have a reflected ray going out. And the angle of incidence equals the angle of refraction. Understand that the angle of incidence and the angle of refraction are with the normal to the surface. So this is called the interface. This is the angle of incidence. So this is the incident ray, and this is the reflected ray. And that's my surface. Okay, then what is the law of refraction? Light ray transmitted at an interface dividing two transparent media is given by N1 sine of theta 1 equals N2 sine of theta 2. Where N, we defined it as V over C, right? And N is the refractive index of the medium.